Hi folks, let's talk more on functions. The last time we introduced functions in Python. Today we're going to talk about more on functions and some more detailed types of functions. Now, before I start, I want to actually review something that we didn't do last time. So what we did was in the lecture 5 code file, a folder, we had a bunch of programs that I had not mentioned and I did not run. I'm going to talk about them now. So if you are using a PC, you can run these programs just like I'm doing in Wing IDE. However, if you are using a Mac machine, the version of Wing I have actually crashes these. So if you go ahead and run this, let's say track mouse program, which is in chapter 6, it's going to crash. So what you can do is, if you're a Mac user, you can actually use a default IDE that comes with Mac. It's called idle. So if you go to your programs in Mac, just go ahead and type idle here. You see it's going to come up, right? So you must have this. If not, you can download online. It's free. Now, so that means Wing IDE on Mac crashes when you try to use this specific library called Turtle library. I'm going to talk about it shortly. But you can use idle and it's going to work just fine. Right? So let's talk about this, and I'm going to run some of this. I'm going to do it on my PC. So let's open up this. So this is a library called Turtle library. I did not mention it last time. So the library is basically a graphics library. It's based on another library. It's called tk-kinter. So it's basically a library that allows you to use your machine's window and draw things on it. Okay, so for instance, let me take box turtle. I'm going to go ahead and run this, right? Let's see what happens. So it's going to draw a box on the screen, right? So this is the box that's been drawn. Let's run it one more time. Look at it. All right, so you notice it just puts the box on the side, and each color, you notice the color changes, starts with red and blue and green and black. Okay, so let's look at this. So this basically imports a library called Turtle, and then Turtle has a bunch of functions in it. All of these functions are change the color, say it goes forward and then turns left, which is like vertical, and then change the color again. So it's a relatively simple library to use, but I don't care about the library per se. I don't want you to learn the library per se, but I'm going to use some of the functionality of this library later to show you or to exhibit some of the functionality about Lambda functions, okay, Lambda expressions. All right, so that's what this does. So you can do more things. You can actually do lines at different speeds and delays. So let's do this. Let's run it briefly. So each of these lines, the speed changes, and also the red line is default speed and default delay. You notice then the next is blue. It's basically slow speed, but no delay immediately. Here there's a delay, right? You notice there is a delay. The delay in terms of when you see it on screen, okay? And then the final one is going to be very fast, and I think it's the slowest, no delay, okay? It's immediately, yeah. It's fast, also there's no delay. So you can actually control all of that on the screen as well with speed and all kinds of delay and update functions. Okay. Again, if you're interested in this, our book talks about this library a lot. You can read more about it, but I'm not really too much interested in this for our purposes. So I'm going to close this. So box turtle, let me close that too. You can also hide the animation. You can just immediately see all of that one at a time, and you can draw an octagon. So it's relatively simple, right? Let's see what it does. So I'm going to actually, and then inside it puts a spiral, right? So let's look at a few things in this code. And this pan color, pan up position is where you're starting from, and then you have to get the pan up and down so that it doesn't draw until it gets there. And then you do this for I in range 8. So that means you're going to have 8 values starting from 0. You're going to 8 times you're going to do. This is an octagon, right? So it has 8 sides. So each side will be 80 pixels, 80 units long. and then you're going to turn 45 degrees. Why 45 degrees? Because if you take 360 degrees, you divide it by 8, you get 45. Okay. So if you do this, change this to leave it at 80, change it to 90 degrees, and do it only 4 times. Let's see what we get. Right, so we're going to get a square. Okay, of course the square, depending on the size, it's going to be different, but you just get a square. That's simple. Okay, you can also change the same thing. So let me go back on this. All right, undo this, undo that. Okay. All right. So you can actually go ahead and change the angle and distance, and it's going to change. So let's increase the angle. I'm going to try this and make this 0.4. Let's see what we get for the spiral. All right, let's see if I messed it up. Okay, I kind of messed it up, right? But this is how it works. Okay, so you change the angle, and then you draw. It doesn't look that bad. It looks pretty interesting, actually. Hey, I like that. Beautiful. All right, so let's stop there. All right, close that. No, I don't want to save this. I messed things up. Let's run this. So this now draws 3 different polygons on the screen. So it has a random library. Right? So it uses random library, and then its polygon has a function. It defines a function, and it has sides, length, and xy is where it's starting from, and the color, and then the fill. Okay, by default it's false. So fill default false, color black means these are what we call, later on we're going to talk about these are called keyword parameters, and these are default values. So when you call this function polygon, and let me not talk about the function, but let's look at a few times where we are calling it. So we're going to call it, you see, with different values. So if we do not define these last 2 values, it's going to be black and false. If we define it blue, the color will change to blue, but however, the second argument, the last argument, fill will stay false. Okay, so this is quite nice, and we're going to talk about this shortly. And in terms of the polygon, it's basically very simple. You just take the sides, number of sides, and then the length, how far you go, and then you divide 360 by size, just like we did 360 by 8, that's 45, and the octagon is exactly the same way. Okay, so the rest is pretty straightforward. Right? And then the fill function, if the fill is true, then the turtle just, and fill is just basically whatever you finish, fill the inside. Okay, that's very nice. All right, and that is it. And let's look at a regular polygon. And this is basically does a lot of random polygons. Okay, and let's run it again. It's going to be random, so it will be different. Right, run it one more time. Let's see how different it is. Okay, so it will be different. All right, so these are pretty nice functions to know, but I do not care about these functions per se, but I care about some functionality that we learn with these functions. All right, so let's leave that to the side. All right, let's talk about it. All right, so in this lecture, we're going to talk about global variables and global constants. We kind of did at the end of last video. We'll talk about functions in modules, how they store and access them. We'll talk about some recursive functions. We'll talk about passing, returning functions to and from other functions. So this is an argument of a function, taking an argument of another function. We'll talk about lambda expressions. These are short, useful functions, ad hoc functions, I say. Then we'll talk about generators, decorators, and partial application. Okay. So global variables, we talked about this. So if a function has a variable inside, it is a local variable. If you want it to be global, what you do is you declare the variable outside, and then inside the function, you just use the keyword global and then the variable name. Okay. So that way you define a variable that is a global. So let's look at global calculator code. Let's see. All right, these are the code that's in section lecture 6 code. So here's the global calculator. So let's look at this. So I'm going to go ahead and run this first. So what this will do is it will give us a calculator that can do many things. Okay. So we can choose to add, subtract, print, help, and quit. It does two things actually. So let's choose A. If I click on A, you'll see that enter the argument 1. Very simple. Right? So it's going to do the, it will give you the result. And then you can choose a subtract, and you can do the same thing. You'll see that it will give you a number and it will continue. Okay. If you click on help, it will tell you add what each of these functions do. And then finally, it tells you that if you hit Q, it's going to quit. Okay. So it's a nice program that is basically allowing you to go through a menu, right, until you quit. Okay. So here you define a help screen. This is the help screen. It just prints the help screen. Nothing specific about this function. It just prints that help screen. Of course, you could have put it inside the code, but it's always good to put it in a separate function so you can always access this. You'll notice that we're going to print this in many times. We'll call this function many times. This is a void function, so it doesn't have any parameters. Then we have the menu. So the menu displays the menu itself, and then it says return the input, and then it says A, S, P, and H. So one of these 5 values will be returned by this function. So whatever the menu will display this, and then whatever the user presses, it will return it as its return value. Then we have three global variables: result, argument, and argument 2. So this is basically 2 arguments. And then we have the get input function. So this basically gets these values. You notice we have this global keyword. So this arg1 and arg2 are going to be defined outside the function. So we don't have to pass them as a parameter because they're global variables, and we use this keyword. So whatever changes we make to arg1 and arg2, they'll be reflected outside of the function. So that's the beauty of global functions. I don't like them too much, to be honest with you, but nonetheless in this setting I'm just showing you how they can be used. And then we have a report. This basically gives you the result. Okay. And then each one, you notice there's this doc string in each function. Explains what it does. And then finally there's an add, and there's subtract functions. If you look at the main, so what it does is basically depending on the choice. So you get the choice by calling the menu function. Once you get the choice, depending on what the choice is, you go ahead and run the functions, get input. You notice why we have these functions, these things in the function, because we don't want to write that code. Get input is long, right? So we don't want to write that whole thing. We don't want to write it again and again, because each of these choices, we're going to run this get input. 2 of the choices actually we do that, okay? And then we call these functions, right? It's relatively simple, and then at the end we call main function. All right. Of course, we didn't have to use global variables. We could have easily passed these and returned them back, but sometimes it's easier to use global variables. All right. So we talked about that. Now, there are reasons to avoid them, because it makes the debugging of your code very hard. Because now you have this variable that is defined outside of your function. In the function, you have an idea what their values are, and it makes these functions now non-portable. So if you take that function and put it into another code, it's not going to work because it doesn't get arguments. So what it does is it relies on the file or the module that's developed in. So because the module has these global variables, so you have to depend on that module. So that's really not, we don't like them in this sense. Okay. Again, so we talked about that. Functions are global variables that use global variables are dependent on those variables. And of course, it's very hard. It makes it hard to understand what the program is doing, especially if the code gets long. These things actually get very complicated, and it makes life hard. So we don't use them really. As much as possible, we avoid them. Global constants, on the other hand, we could use them. It's like a pi value. It is defined in somewhere in one of the modules of Python. So you can actually define. There's a global constant pi. You can actually go ahead and look at it. So let's, if I can remember what it was. So let's go ahead and look at pi. So pi is, as you know, right? So that's what we're going to look for. So it's a math module. So let me get this way so you can see. So we're going to do is import math, And then if you look at math.py, you'll see it's going to be a constant. So it's a constant start in math module, right? So it's okay if you're using constants. It's okay to use them as global constants. All right. Now we talked about keyword arguments. These are in functions. These are used as default values. It also gives you another flexibility. So you can actually, when you have keyword parameters, this parameter and value pairs, you can actually change them orders as long as you provide parameter and the key, a parameter and value. So you can actually move them around inside your parameter list. Okay, right? So you can actually mix possible mix of keyword and positional arguments, but positional arguments must appear first, just like in print function. But then the keyword arguments appear afterwards. Okay, so you remember your print function. So you can actually have similar things like that. So let's do this. I'm going to actually, let me draw it up here. I'm going to do it right here. So in the print function, by default, the first thing is the positional parameter, so argument. So let's say hello. All right. And then the next thing is the other argument. So let's make this world. Okay. And then the third argument, if you don't do anything, there's nothing to worry. Okay. But then you can actually put the third argument. It could be a separator. Let's put a tab. Right? And then you can actually put and before that because they are keyword arguments. The order is not important. So let's make this backslash and. And it's not backslash and. Let's put a dollar sign. Okay, at the end. Okay. So now, if you look at this function, I can actually go ahead and run this. And I can actually go ahead and run it the other way around too. I can actually take this, change the position of the keyword argument. So the only constraint is you have to have them in that order. You cannot have them in this order. You cannot take hello world and move it to the end. This is not allowed. Okay, so this will complain. Okay. So always put the positional arguments first without keywords and then the keywords at the end. Okay. So here are some examples. Here's a sum that sums from n to all the way to 100 if you do not give anything. And you can also have a default value at the beginning, and so you can have the starting and the ending value as default, or you can also have the reverse. So this is not allowed, but you can have it the other way around, right? So you cannot have the keyword argument first. So this, you gotta change it to red. All right, so this is not allowed, and clearly these are other ones are allowed. Okay. So only thing is about the location. All right, so it's a relatively simple function. So you can also have recursion, just like in any programming language, you can have recursion. So like n factorial here, you can define, here's the definition, you can actually write a code to calculate factorial through recursion. And this is not the only way to calculate factorials, but this is one way to do it. So what you do is, you have a function, factorial function, so it returns 0, right? If n is 0, it returns 1, because 0 factorial is 1. Else it takes whatever the return value is, n value at this point, and then calls itself. So what it does is this function here, it calls itself. So that's why these are called recursive functions. It calls itself with n minus 1. So you start with n, let's say 5, and then you call factorial n minus 1. So it's going to call it with 4. And 4 will call 3, and 3 will call 2, and finally you're going to hit 0, and then it will be 0 factorial will be 1. Okay, so what is this? Is basically, this is your f of n, and this calls f of n minus 1. So let me actually just write f of 5, and that calls f of 4, that calls f of 3, and f of 2, and so on. Okay, so that's what is happening here. Recursively, that's what's happening. All right. Have some examples you can go ahead and try. You can also have non-recursive version of this. you basically have the product set equal to 1, and then you have a while loop inside. You continuously multiply until you actually n becomes 0. Okay, so this one is pretty nice because here you have a condition. So while n, right? So n is for any number. Remember, 0 is false, and any number other than 0, non-zero, is true. Right? So this while loop ends when n becomes 0, and inside the loop you actually decrement n by 1. Right? So this is how this one works. Pretty neat. I like both of these functions. I'm not going to run them, relatively simple to run, but you can go ahead and run them. Now, so in large programs, it's impossible to write everything in one single program, one single module. So what you're going to do is actually you're going to split this in multiple modules. So it's called modularizing. So you're going to write certain functions in certain modules, and then you call them. It's relatively simple actually. So even here, we can actually call any function defined outside. As long as it's in the same folder, same directory, we can call them. So let's give some examples here. So let me get this down. All right, so let's do it. Like for instance, this has a function. Let's see, it has a main. So this has a subtract function, right? So subtract function. But the problem with this is it requires to use global variables. So I cannot really use any of the functions defined here outside of this. So this is gone. So I'm going to close this. All right, let's go ahead and try to run this GCD function by importing this file and then calling this function. Let's see what we get. So what I'm going to do is I'm going to create a new file in the same folder as these. These are in my lecture 6 files. So I'm going to go ahead and let's import GCD. Okay. And then I'm going to, we got to save this. So I'll save this as trial. I'll save this in the same folder. So this is downloads, lecture 6 code, save. There is one already created. I'm going to replace this, replace. So let's go ahead and run this. Let's call this function now. Let's name this as, give it an alias as g, and then call this function. Let's say g.gcd. Let's say 10, 45, and 60. Okay? And then let's assign it to a variable t, and let's go ahead and print this variable. Right? So this is what this function does. So we're importing the class. So it's module, this file. So let's go ahead and run this. You see, it's running a lot of things. This is our result. We are looking at this result. This is what we want to get. Because if you look at the GCD function, that's exactly what it does. Basically, it does a different methods to find GCD. It's called the Euclid's method. It's a different kind of method. But then it does find it, but nonetheless, it does all kinds of things. What is happening is, it actually, when it imports this file, it actually runs the whole file. So if you run this file, this is exactly what you get. You get exactly the same thing except that 15 at the end. So if you go ahead and run trial, so you call load GCD, it's going to run GCD, and then it's going to run on top of it this function. So it will run GCD, and at the very end, it's going to run 15. Okay? Right? So it's somewhere at the beginning, it's running. So what we need to do is, we need to go to GCD and write something specific. We have to say, so what we need to do is, we have to say if name is equal to main, go ahead and run the main, right? So it checks to see if this specific module is being called. Now, if you go ahead and run this now, it's going to run just like before because this is the process that's being called and its name is main. However, if you go to your trial, it's not going to run. But there is one problem here. We have to actually go ahead and rename. We have to rename this module because the module and the function name are the same. That creates a problem. So if you just do this, you'll notice what happens. It's going to go ahead and do the exact same thing as before. So what you need to do is you need to rename this module first. So go ahead and rename this by basically we just save as and go ahead and put X there. Right? And continue. And now when you import this module as GCDX, this is different than the function name. If you run it, you'll see that it's just going to run that function. It'll just give you 15. Right? Alright, so this is the import. So it's a bit different than Java, because in Java the module names are exactly the same name as class. Here, that if the function name is the same, it creates a clash. It still runs the GCD. So make sure that they are different if you're going to call that function from any module outside. Okay. So you can do this in many different ways. Of course, you can make very complex programs using this structure. Okay. Alright, so what is a module? It's simply any file that contains Python code. Just like any Python code, it ends with .py. If you notice, all of the modules that we import are actually on your machine, like math module. Somewhere there's a file called math.py. Okay. All right. Some examples in the prime code, for instance, we can actually use the prime code, and using prime code in this, let's look at this. Let's see if I have those here. What I'm going to do is go ahead and close. I have too many files open, I realize. I'm going to go ahead and close this. I think I'm done with this for now. Okay, I'm going to go ahead and close the trial for now too. Let's now save this. Alright, so we do have a prime code. Here's the prime code. It has, you go ahead and run. It does nothing. Okay, it's just a module that has no main. It doesn't have any functionality. It doesn't print anything. But I can actually go ahead and use this in prime code. So this is in using prime code. So let's go ahead and find this. Alright, so using prime code, what it does is it imports directly the isPrime function and then uses that function. You notice since I've directly imported that function, I don't have to say prime code dot isPrime, so I can directly use that. So this is now going to go ahead and use that prime function, and let's go ahead and alright, so you can continue, enter. 4 is not a prime number, 5 is a prime number, 9 is not, right, 13 is, and then finally 999 to stop. Okay, so this is quite neat, very easy to use, very simple statements to import the module or a specific function. Now, in Python, you can also treat functions as data as well. So you can actually take a function like square root function and assign it to a variable. Okay. So now function becomes a data, and then you can actually say x16 is actually, this is actually internally square root 16. Okay. We can also pass a function, but not the value returned, as a parameter to another function. This is a very powerful tool. So for instance, we can define our arithmetical evaluation. So these different functions, let's take a look at this. I think I do have this in your notes. So this is, let me close the ones that we've used before. Prime code, we've done that too. So now we're going to look at this one, right? So what this does is basically I define these functions, add, multiply, and then I define the function evaluate. What the function evaluate does is it takes f, this can be any function, and then two variables, x and y. So when you call, and then returns f, x, and y. So this f is a function, whatever that function is, it can be add function, multiply function, since I have two functions, and then it basically says add 2, 3, it actually goes ahead and calls. You can call directly these functions, they're in the same module. You can call them directly, or you can actually call them using evaluate. So because evaluate, given the function add and multiply, it can actually evaluate this way. What this gives you is basically, depending on the variables, it gives you writing the same code and being able to call different functions. Okay, So it's quite powerful, right? So the trick is make sure that evaluate takes a function as a first parameter and then returns the function. It calls the function. This is very powerful. Relatively simple, but very powerful. So this ability to be able to pass a function as a parameter to another function is very powerful. So basically it allows programmers to develop code that interoperates with a larger software framework. So you can actually take a function from someone's module and then treat it differently. Turtle Graphics is one of those frameworks, and the functions that they actually use, we can actually use the module to, like on-screen click, that takes as a function as a parameter. So for instance, so let's look at track mouse and place square. So I'm going to look at these. I'm going to look at both of these. In my PC. Okay. So I'm going to open track mouse. So these are under downloads, same as this lecture 6 code. So I'm going to get track mouse first. Alright, so let's open that first. Alright, so let's go. What does it? It does is very simple. So it says report position is a function, reports values of x and y. And then what it does is it prints the value of x and value of y, and then it flashes the screen. So basically you take this function and give it as a parameter to on-screen click. So what it does is every time you click on the screen, it calls this function. And that function goes ahead and prints basically the location. So I'm going to go ahead and run this in the PC. So you notice, watch this. So every time I click on the screen, it tells me the exact position. Somewhere in the middle is 0, 0. Okay, I'm not quite there yet. So let's see if I can get exactly in the middle. Not quite. All right, somewhere there you can actually see. So the corners. This is the size. Given the size of my screen, it gives you the position, and then the middle is the 0, 0. Okay. So very nice. So the key here is being able to pass this function to on-screen click. So on-screen click is defined such that it takes as a parameter, it takes a function, right? So, and whatever that function you want to do, and it actually takes it and does it for you. So the next thing I'm going to do is I'm going to actually now write a function to draw squares on the screen. I'm going to pass it to on-screen click. So every time I click, it's going to call that square function. So let's go ahead and do that. And this one is called place squares. So let's find this right here, this one. So first of all, let's run it. Let's see what it does, and then we're going to explain. So every time I click on a location, XY location, you see it puts a small square. So what I'm going to do is, let's look at this draw square function. This function actually uses the turtle library to draw a square. And I can change the square. I can actually change it, make it a bit larger. So I'm going to make it 100. So let's see if it's going to be huge. All right. And let's go ahead and do this. So now it's going to put a bit larger squares. Right? So I can go ahead and change the function as well. So let me actually go make this 120. So let's see what we get now. I'm going to do it 3. Okay. See what we get. Now I get triangles. Okay. Very simple. All I did was change 4 to 3 and then change degrees to 3. Right? 360 divided by 3 is 120. Okay. So now it becomes a square. Right. So it's relatively easy. The power is writing this function and pass it into a library function. So it means I did not write the library function, I cannot change it. So that means if I want to modify what I'm doing on the screen, since I cannot change that function, actually it's an open source, I can change it, but technically what you do is you basically say, I write a function and I pass it to you, and then depending on the action that you get, you actually run that function. Sometimes the parameters also be gathered by the library function as well, but in this case, the parameters are actually passed. X and Y parameters are passed into the raw square. So when you click on this X and Y, the turtle library function gets the X and Y and passes as a parameter to the raw square. It's pretty neat. All right, the next thing in this setting is what we call lambda expressions. So the lambda expressions are basically functions, but they are not functions. So it's basically, if you take this function, right, evaluate function, so you return f, but that f here can be any function. So earlier we actually wrote these f functions. Do you remember? We actually wrote add and multiply, and we passed them into evaluate. Okay, right? But f can be also created on the fly. So, and this is simple. These are called anonymous functions, and let me show you what it looks like. So the syntax is very simple. You have the lambda keyword, and then there's a parameter list, and then the expression. The parameter list can have as many as you want, as many as parameters as you want, and then the expression. It's just a one-line function. Okay? So if you look at lambda evaluate, what happens is instead of add and let's say multiply, I'm actually giving evaluate this function, a lambda function. And what is lambda function? It has two parameters, x and y, and this is its formula. It just multiplies them. And then what it does is it takes two values, 2 and 3, right? So it's a function actually, but it's a different function. So if you look at the expression, it has some rules, of course. It's not as powerful as the DEF is more powerful. Nonetheless, there is still use for lambda expression. For instance, you can have an evaluate, and here you can actually have a very complex function as well. It doesn't have to be simple. You can put any function here as well. Okay. You can also put conditionals. It's possible to put a conditional as well. What you cannot put is, you cannot put a statement, like print statement cannot be there. Conditional is fine, but you cannot have if and else statements. They're illegal. The function value, of course, it will return, but you cannot have the return as a keyword. Assignments are not possible in lambda expressions. So they are a bit simpler functions. They're anonymous functions, and loops are not allowed. So there is no looping while or for loops. Okay. So simple function, so you can actually pass it as a parameter. Here's an example I'm going to give you, a couple of examples. So you can define f to be a lambda x, it's a 2x. So, and then you can call f function with a 10 and it will give you 20. Alternatively, this is equivalent. So this is actually equivalent to writing the function, okay? And of course, it's limited, but it's one line, and you can pass it as an argument to some other functions. Right? So on-the-fly functions. The reason is because if you want to use a function and use it on a, let's say, remote live module, you have no access to that remote module. So you cannot really modify it. What you can do is you can pass a function, and we're going to show you how that is done. So the comprehensive example is this plotter example. So I'm going to go ahead and do it. So let's look at what plotter does. All right, so what did I do? So let me connect to my PC again. All right, so let me open plotter. All right, so what plotter does is it has this initialize plotter function, okay? So the function has a bunch of variables. Then it has a bunch of global variables. So for most of it is fine. What I want you to notice is I'm going to actually go ahead. I'm going to define a function called plot. All right, so it does plot, and I'm going to continue. Finish plotting, quad functions. So what I'm actually doing is I initialize the plotter. So this is the size, location of the plot. And then what I do is I actually call the quad function, okay? And then I call it, so I plot the quad. And then I go call this plot function with a defined function and then lambda expressions. Okay, so these two are lambda expressions. So what I'm doing is actually I'm printing this quad on the screen. And then I'm going and printing this function. What is this function? It's just a simple x. And this is 3 times sinus x. Okay, so let's look at what it looks like. So first is x. So it will be this quadratic. And the second one is, this is x, y is equal to x, this is like 45-degree angle, and this is your quad, that's the red one, and then the green is your 3 times sinus x, this is like sinusoidal line. Okay, so how am I plotting them? I'm actually creating a function called plot, and this plot function uses the library, turtle library, to print things on the screen. Okay, set the position and the increment and print it on the screen, right? And then I have this, let's see, where is it defined? The quad function that I defined right here. Very simple function. I pass it as a parameter. Alternatively, what I do is I pass lambda expressions as parameters. So whatever I give to it, it just prints it. So let's get something else. I'm going to go ahead and change this function to 4, and let's see what we get. Okay, so it's going to be a different sinusoidal line, right? So it's just frequency is a bit large. All right, so very simple. Again, you see that if I can, that statement, you'll see in most of the programs from this point on, you'll see this statement. So because most of the programs that we use now they can be used as modules that will be imported in other programs. All right, so the key here is understand that we can define ad hoc functions, anonymous functions, and pass it as a parameter. Okay, very powerful to do. All right, so let me get rid of this. I can. Sorry, I'm in the wrong screen. Here. All right, next thing we're going to talk about is generators. Generators are a specific kind of functions. So they're functions. What they do is they allow you to have a function that remembers this past. Okay, so when you run a function once, next time you call that function, it doesn't remember the previous run. So it relinquishes all its memory. But what you can do is you cannot have a function that remembers about its past calls, past invocations. If you want to do that, what you do is you create a function that's called generator. Generator is very simple. So it's basically, like for instance, what you can do is you can actually create this program, function memory, you can create a function using global variables. However, this is not the way we want to do. What we're going to do is we're going to actually create a generator. Okay? So what generator has is a function. Only specific thing is inside it has this yield function. Instead of return, it has this yield. So what does it do? Every time you call this function, it's gonna return the next yield. So first time you call this function, it will return this. Next time it will return this. Third time, fourth time. Okay. So this is called a generator. So it generates every time you call it, generates a return value for you. Okay. So for instance, we can create a generator, xgen, and then go ahead and run it. Every time you do it, you'll see it's going to continue to give. So if you define this generator, yield sequence, and then call this, you'll see it's going to actually call it until it goes all the way to the end. At the end, it's going to actually, if you use the next function, it will give you an error because it will run out of the range. Right? You can use for loop in generators. You can put them into for loop as well. In this case, what they will do is, instead of next, you can actually put it in a for loop, and it will actually yield each item one at a time. So let's go ahead and run this. This is, I think I have this code. The previous code I don't have next, but I'm going to go ahead and look at this. So this is for generator. Okay, let's close this one. Yeah, this one using global variables. This is okay, but not great. So we're going to do this for generator. So what it will do is, every time I call this generator, it's going to give me one of these values and print them one at a time. Okay, so that's what it does. Okay. Now what I can do is I can actually take the generator, the whole generator at once, and put it inside a list. I can just say L is equal to, I can use this list function and put inside the generator, whatever generator is. Okay, and the name doesn't have to be gen, it can be anything. As long as there is yield inside, it's a generator. So I can go ahead and print L. go ahead. You see that it's going to print the whole thing as a list. Okay. Now, what generator is it actually allows you to only go forward, and you can go, no, you cannot go backward. It doesn't also allow you to access directly. It only allows you to access one at a time. Okay. But as a list, I can go ahead and look at each element of the list. I can just say L2. You'll see it's going to go ahead and find it. But with the generator, you may possibly do it. Let's go ahead and try it. All right, so let's go ahead and see if I can get the second value. Okay. All right. So even if you go ahead and define a new variable g is equal to generator, you will still not be able to get it. Okay. So if you try to go and to a certain element, generator will not allow you to go ahead and see it. Okay. So you cannot go to g0. Right. So the generator only allows you to one at a time. However, ranges allow you to do it, so I can actually go ahead and create a range R, and let's say range, let's say 10. So there are 10 values in it. Okay, go ahead and run it so that it's defined. So I'm going to go ahead and now look at R2. You'll see it's going to allow me. So the range allows me. So range also gives me one value at a time, but it's not a generator, so it's something between a list and a generator. So it allows you to list-like access, but it is not like generator-like access, right? All right, so it creates multiples. So basically, you give value m, let's say m is 3, and it gives you multiples of m, starting from 0, 1, 2, 3, 4, 5 times. Okay, so it's basically n times. So this is 1, 2, 3, 4, 5, and 6. Okay, so it's going to multiply 3 times 0, 3 times 1, 3 times 2, 3 times 3, 3 times 4, and 3 times 5. Okay, so that's what it's going to give you. All right, so let's go ahead and run this. I've run it already, so I'm going to go ahead and run it one more time. You'll see it's going to give me all the way from 0, 3. Every time I run it gives me. So I basically go through, in the for loop, I go through the generator and run it one at a time and print it. Okay. So let's change this. So let's get multiples of 2 and let's get 10. Right. So you notice now it's going to have 0, 2, 4, and so on. Right. So it just finds multiples. All right. Now, the functions can also be defined in functions. We call these local functions. So you can actually define functions inside functions, right? So here you can take the function and compose it into different parts and call a main function like a main. This is like a main, okay? Alternatively, you can actually make functions part of the main. So here, what you do is you notice the indentation. What I'm doing is actually I'm making these local. So they are not accessible outside, but they're only accessible inside that function. You can also return a function, and you can also use what is called a non-local function. Okay. So here the function, what it does is it basically creates a counter, and the counter itself is a function. It returns a function. So you notice it returns this function. So every time you call this create counter, it creates a counter for you up to n, and then returns that counter. Okay. So the counter itself is, you notice it uses a keyword non-local. So that means this count variable is not the local. It's not the local count. Okay. But it's not global either, because it's not a global. So we are inside a function. So this is like global, but used in functions. If it was global, it was going to look outside of this function, like main function, but it's not global. So what is this? Basically, it is non-local, so it's not local. So there's that keyword as well. So what this does is basically it returns this function every time, and then the function itself has a count and is 0, and count all the way to n-1 is going to go ahead and increment and return the count. Okay, so it's going to return this count. So let's run this. So let's see what it is. So this is a local counter. Actually, go ahead and close this too. Let's not save this. Let's find our local counter. Do I not have it? Perhaps I don't have it. Huh, I thought I did have it. So let me try one more time. Let's check it. If I don't have it, I don't have it. That's okay. Alright, so let me, might not have that there, but I think I have it in Python. I'm just gonna search for it, see if it is here. Huh. Alright, so let me search for it and get back to you. Alright, I'm back. I searched for it. Unfortunately, I never created this function. Okay. So, alright, I want you to go ahead, copy and paste this. You can do it from your textbook. It is 825, listing 825, and you can go ahead and run this. So basically, you can create a counter 4, and what it will do is the counter will print each time you run it. It's going to print these values. Okay. All right. You can also calculate derivatives using these functions. So using these lambda expressions. This example, I'm going to explain it quickly, but not run it. I may have it or may not have it. So you basically, what it does is this function, derivative function, returns this function. And what is this function? This is a numerical derivative. So it calculates the numerical derivative. It's from your calculus, you may know this. It's basically fx plus h minus fx divided by h. That's the definition of derivative, right? So what this does is basically, it basically calculates the derivative of a function, okay? And you give it a function, and the function in this case is this, okay? And then you give it an h, and it calculates the value of derivative. So right here, okay? So that's the h value, okay? So and then the answer is the exact derivative. So this is what? 3x squared plus 5, right? So this is my f. And I know dx is equal to 6x, right? And this is how the derivative. So the answer is 6x. We're going to see how the numerical derivative is close to it. So let's go ahead and run this. If I have it, I hope I do have it. Thought I did have it. I remember running this function. All right, here we go, derivative. So let's go ahead and run this. So you notice now it's going to create a table. The table has the estimated derivative and the actual derivative. It's pretty damn close, as you can see. Okay. So what I'm going to go ahead and change the value of h. Okay. I'm going to make it larger. All right, so where is my h value? Right here. Alright, so as goes to the approximation is better, right? So now you notice there will be a huge difference. Not huge, but there's a drastic difference, right? Right there. There's a little bit of a difference in terms of calculation because it's off, right? But the key here is that I'm returning a function. Here, the key is this function is being returned from this function, right? So it takes a function and returns a function. Now, this idea of being able to take a function and return a function allows us to create what is called decorators, and these are also called annotations. Okay, right? So what we can do is we can define a function with another function. We can write a function that returns a function as its result, and we can use these two abilities to create a functionality that we want and assign it to an arbitrary function. Okay, so there's a function that we did not write. So what we want is we want to change that function to behave differently. But it's a library function. We cannot go ahead and change it. Or it's somebody else's function that we don't have access to the code. Let's say it's a web services function. In that case, what we can do is we can actually go and decorate that function, annotate it. Right? Simple example. I'm going to show you this example and we're going to come back to this. So let's look at the undecorated example. All right. Let me clean some of these. All right, here we go. So here's a function. I have a bunch of functions. There's a I'm importing random range. There's a max function, there's GCD function, there's summation, right? There is start rect function, okay? And if you run these functions, this is what you're gonna get, right? Right? So if you want to change any of these functions and act it differently, you have to go into these codes and change them one by one. Right? We can change it one by one. So if we have a function like this function, and we want to make it so that it does something differently. So we have the max function at the top, we want to add and change it. So we want to say there's a call string. So we want it to tell us what is being called, x and y. And then print calling the name of the function, the call string, and put the result, okay? And then print returning from. So let's go ahead and run this. This is called poorly decorated. So the undecorated is this, right? This is what we get. Let's look at poorly decorated. The poorly decorated actually means I go to each of these functions and modify them one by one. You notice all the functions has this, okay? So what this decorator does is there a way I can take these functions and make all of them do the exact same thing? You notice it's the same thing that's been done, right? So we create a call string, print the calling with the call string, and then go ahead and do things, and then print at the end, returning from the result, returning from this call string, okay? So the call string here is, you notice it is the max of x and y in one case. The other case is GCD of m and n. So it's not the same thing. Call string changes from function to function. So it's not that easy. So we can do this with a decorator. So we can decorate a function like this. Right? So we can actually create this decorator. We say define show, call, and return details. Again, this is what we're doing. And then we say take the function name, f.name. You notice f, for each function there is this attribute name that's internal. We can access that. And then we can define another function here, execute augmented. So execute augmented is the decorated version of this function. What it does is it takes the name of the function right here, and then along with x and y, it creates this call string, and then prints the returning from this, and then the result here, you notice it returns the result, okay? And then this returns this function. So this outside function returns this function, and inside the function, depending on what function called this, which f, it gets its name, and then creates a decorator and sends it back. Okay, so then we do, without altering our original functions, we design this decorator, and then we can call them using this decorator. We can just create augmented max, say that say show and call return details, and so we basically pass our max function to the decorator and define a new function. We call that augmented max. We do the same thing for GCD, summation, star rect, range. We do all of that. Okay, so once we do this, what we can do is we can go ahead and call. So this is, if I have this, let's look at it. This is simply decorated. So here's a decorator function defined, and I don't change original functions. What I do is I just now call them using augmented. I define these augmented functions using my decorator and call them, right? Alternatively, there is one thing even better. Again, you can look at what these are returning. So even better is I can actually define an annotation. So if each function, I can annotate it. This is called annotation, or then decoration, right? So I basically say I annotate each function. Sorry about that. I annotate each function with this at show call returns. So basically each function now acts differently. What I do is I now call each function as usual. So let's look at better decorated. I think this is the name of this file. All right, right here. Simply decorated. I have it here somewhere, but I couldn't find it. Yeah, it's this one. Sorry, decorator. I couldn't find the name of it. So here I'm actually I'm creating exactly like before. I create my decorator function, and then go ahead and each one I just put this annotation right before the function, and then I go ahead. I don't have to define anything. I can just call each function separately, right? And then go ahead and run this. You'll see this. It's gonna give me the exact same thing. Result is the same, but the way we decorate and how we use the decoration is a bit different. Now you can also decorate the library function. This is actually a pretty neat thing. You can actually take a function like here, rand_range, and we can actually take it, the function, and define it. So remember, this rand_range is a function that we don't have. So the rand_range is a function that we actually import from the random library, but we decorate this differently. We cannot annotate it because we don't have access to the function definition, so we cannot go and put the annotation. But what we can do is we can actually go ahead here in the random range. We can go ahead and use our annotation to change how that function behaves. Now, of course, the function has to have similar kind of parameters. So it cannot have, most of these functions, as you notice, they have two parameters, and this rand_range has to have the same parameters as well. And you can do also max function. It's a similar, as long as it has two parameters, you can decorate it with this decorator. You can, if you want, you can actually nullify a function as well. You take a function and you basically just do pass. Remember pass? So this function now becomes empty. So now you turn this empty. So take a function and pass it to nullify. Actually, the function now is useless. Okay? So you can do that as well. Now, the partial keyword allows you to use function with something like a default value. So here's a function. So we import, first of all, this is how you get the partial. So what you do is you define add function, and then you define partial add. So what this does is add new function. It always takes one value, but the second value is default or fixed. Right, so the partial is you take a function, you actually make parts of it fixed. Okay, so it allows you to make, once again, sorry about that. So it takes a function, right? So you first import it, it's in functools library or module, and we define our function as usual, and then we define another version of this function, which is partial. Original function stays, but this new version, it always adds 5 to whatever value you give to it. Give one value, it will add, right? So now if you run this, it's going to give you 8. Okay. So good use of partial is when we need to interface with library functions and we have no control, we can actually use partial and set portions of it and adapt those functions. Okay. And the good example in the textbook is this compare rows. And I don't have that, I haven't created it, but it's on the textbook. You can look at this. Partial is kind of easy in this setting, but it can get really complicated, and I want you to look at this example if you're interested. Again, this is optional, but you can actually take a look at it. All right, so this wraps up our discussion of more on functions. So as you notice, functions are very powerful. So you can take an argument as a function and return a function, and those actually allows us to create what we call decorators, right? And Java, they are called annotations, and they're very common and they're used a lot. Okay, especially when you do remote method invocation, RMI, there you have to really decorate library functions to be able to do that. All right, this wraps up today's talk. I'm going to talk to you next time about lists. Bye now.